These notes are on graphing rational functions, and this is really the culmination of this module. All the work that I've done up until now is really to get to this place where I can graph this function. So the first thing I'm going to do is I am going to factor the numerator and the denominator. So I have x squared plus 5x plus 6, x minus 5 times the quantity x plus 2. The numerator can factor further, x plus 3 times the quantity x plus 2, all over x minus 5 times the quantity x plus 2. Okay, so there are a couple of things that I can see straight away. The first thing that I notice is that I have an x plus 2 in the numerator and the denominator, which means that if I were to graph g of x and then also graph the related function h of x, that they would be almost the same. The one catch being that the g of x function has a hole. That's what this gives me, is it gives me a spot where I have just one point that I can't be when I'm on a continuous portion of the graph, making it discontinuous. And in fact, if you graph g of x and h of x on your graphing calculator, it's not going to show you that discontinuity. It can't because of the pixels and the computer, the way the computer works. So the first thing I'm going to do is I'm going to say I have a hole at -2 comma, and I can actually find that point for that hole by plugging in -2 in for x into my h function. So -2 times 1 all over -7, which gives me 2/7. So when I'm graphing this function, I will have to go back and make sure that I have a hole at -2 comma 2/7. The other thing that I notice right away is that my denominator has another piece, and so that means that I have an asymptote. I can't have my denominator equal 0. That's the whole point of the holes in the asymptotes. I can't divide by 0, so I need to, recognize that there's something different happening in those places. And the last thing is that I have zeros at 0, 0 and -3 comma 0. I don't have a 0 at -2 comma 0 because that's my hole, and so it happens not at 0. When y is 0, it happens at a different location. My next step is to notice that this original fraction is an improper fraction, which means that I'm going to have a slant asymptote. So that here. And so what I'm going to do in order to get that slant asymptote is I'm going to have to do my long division. So x squared minus 3x minus 10 divided into x cubed plus 5x squared plus 6x plus 0. So x cubed minus 3x squared minus 10x. Subtract, 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 8x squared plus 16x plus 0, 8, 8x squared minus 24x minus 80, subtract, 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 leaving me 30x plus 80. This is my slant asymptote. Sorry, 2 mistakes there. First, this should be 40. And actually, this is my slant asymptote. So y equals x plus 8. So I now have almost enough information to graph this, but before I can finish what information I need, I actually have to kind of fill in some of these pieces. So I am going to start my graph. One, 2, 3, 4, 5, and there's my vertical asymptote. I have a slant asymptote at 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm going to need a much bigger graph for this. Let's extend this. 1, 2, 3, 4, 5. One, 2, 3, 4, 5, 6, 7, 8. Slope of 1. Okay, so I now have sort of my boundaries in here. Oh, and I also have my 0. Let's not forget that 0. Our 0 happens at 0, 0, and at -3, 0. So I now have my graph kind of split up into these different regions. I have, questioning sort of what is happening over here when my x is smaller than -8. What's happening here between -8 and -3? What's happening here? 1, 2, 3, and I can't count. What is happening here between -3 and 0? What happens between 0 and 5? And then what happens after 5? So in order to figure this out, I'm going to have to actually look at these various regions. So I'm looking at when x is, let's say, when x is -9, -4, -2, 4, and 6. So that gets me a number over here when I'm smaller than -8, when I'm between -8 and -3, between -3 and 0, between 0 and 4, and past 5. So my various regions are cut up. And so now what I'm going to do is I'm actually going to find out what sign, whether or not it's positive or negative, for each of those regions. So I take my g of x, and I'm going to put in this -9. And I'm going to go back to the factored form for this. I'm going to cover this up so that we can see the factored form more easily. And I'm actually not going to pay attention to the numbers so much as the signs. So a -9, I should say g of -9. So -9 is a negative. Plugging in -9 is negative. Plugging in -9 is negative. On the bottom, it's also going to be negative, negative, which gives me a negative number. So that means that I know that over in this region over here, my graph is a negative. So let's do g of -4. So I've got negative, 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 which gives me a negative. So again, I know I'm down below here at this point. G of -2 is going to give me a negative, positive. Oh, whoops, I can't pick g of -2. I'll have to pick 1. Remember, I can't pick -2 because that's where the hole is. So that's going to give me a value that, it's going to actually give me a numerical, it's going to give me a 0 divided by 0. Okay, so negative, and I rewrote -2 again. -1. So I have a negative, a positive, and a positive, all over a negative and a positive, which gives me a positive. So that means between here and here, my graph is above. So I'm somewhere above. G of 4. G of 4 is going to give me a positive, 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 all over a negative, positive, which is negative, so I'm down below here. And G of 6 is going to give me all positives. So positive. So we'll start with the G of 6. That means that I have that shape happening. Down in this space, I'm below my axis up until -3. And then I curve up, and then I curve back down. And again, I'm kind of following those asymptotes. And my graph looks a little wonky, but I've got the main features filled in here. The one catch is that I need to have my hole, and my hole happens at -2, comma 2, 7. So actually, this graph is way higher here than it needs to be. This graph should be actually pretty flat in this space, because at -2, I have a hole at 2, 7. So it kind of has more that shape where it's a little flatter in that area. So that's the graph of g of x. Let's look at a second example. In this example, we do not have an improper fraction. So there's no slant asymptote. So I'm going to start off by factoring this. X plus 3, x minus 1, all over x plus 2, x minus 5, x minus 1. So right away I see I have a hole. And my hole happens at +1. And again, if I do that lovely little trick where I say, well, g of x is the same function, except that I've removed my hole. And if I plug in 1, I'm going to get 4 over 3 times -4, which is going to give me -1/3. So I will have a hole at the point 1, comma -1/3. I have an asymptote right here when x is 5, and no slant asymptote since I don't have an improper fraction here. And then I have a 0 when x is -3. So I'm going to start off by putting in this information. So the first thing I've got here is I've got a asymptote at x equals 5. 1, 2, 3, 4, 5. I've also, have an asymptote at x equals -2. 1, 2. And I have a 0 at -3, comma 0. So those are the big pieces of information. So now I need to figure out what is happening between all of these, what's happening to over here on this side and in the middle and on this side. So I am going to plug in the numbers -4, -2.5, 0, and 6. So h of -4, and again, I'm only going to pay attention to the signs, is negative, negative, over negative, 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 which is negative, which means over in this direction, I'm underneath my y-axis. H of -2.5 is going to give me positive, negative, 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 which is going to give me positive. Oh, sorry, technical failure. So that means I'm now above. Then I have h of 0, which gives me a positive, negative, positive, negative, negative, which is negative. So that means that I'm somewhere down here in this region. So we'll come back to that in just a second. And then h of 6. H of 6 is going to give me all positives. So, and I don't cross my x-axis because I have no more zeros. And then I have to pay attention to this point, 1, comma, -1/3. So I've got a hole there. And there's my graph.